Okay. Now we're going to move on to radian measure. Now, how many degrees are in a circle? 360 degrees in a circle. How many radians are in a circle? Well, that all depends. Okay? The word radian is like the word radius. So those two things are closely related. Okay? So, let's say we have a radius of 1 centimeter. Okay? There's 360 degrees in a circle, right? So how long does it take me to get around a circle like this if it has a 1 centimeter? Okay? Going around a circle is called the circumference. The circumference of a circle is 2 pi r. So the circumference is 2 times pi times, in this case, 1. What's 2 times pi? Well, it's 2 times 3.14159.265. But basically, it's like 6.28. So this would be approximately 6.28 centimeters around that circle. Okay? But what if the circle was 2? Well, if it's 2 centimeters, it would be 12.56, and so on. Okay? So, we don't want radians to change all the time, okay, depending on the distance of that. So what we say is we're going to make the radius 1 unit. And we're going to call this the unit circle. Because my 1 unit could be centimeters, it could be miles, it could be whatever. Okay? So if it's 1 unit, what's my circumference going to equal? 2 times pi times 1. Or, to be exact, we call it 2 pi. Now, this distance is 2 pi radians, which is equal to the distance around a circle in degrees, 360 degrees. So, in a circle, there are 2 pi radians, and there are 360 degrees. This is the trig value of finding distance around a circle. This is the geometry value of finding the distance around a circle. Okay? Geometry, we use degrees. Trig, we use radians. But we're going to use degrees quite often in trig as well. Okay? So, if I had 240 degrees and I want to convert that to radians, 240 degrees and I want to convert that to radians, I know that there are 2 pi radians in every 360 degrees. Now, why did I put radians on top and degrees on the bottom? We want the degrees to cancel out. It's a unit conversion, just like we learned in Mr. Swenson's class when we were all freshmen. Well, I learned it in Mr. Potus's class when I was a freshman, but that's here nor there. Degrees cancel. Okay? So, 240 goes into 360. 2 and 3 times, because 120 goes into each. So what's 2 times 2 pi? 4 pi over 3 radians. Now, we're not going to write radians every time. So when you see 4 pi over 3, you just understand that's in radian form. We don't have a radian symbol. Okay? So when there's nothing written, then you know it's radians. Okay. All right. So what is 165 degrees turned into radians? Now, we can make this a little simpler. If 2 pi radians are in 360 degrees, pi radians would equal how many degrees? If we divide this by 2, what should we do with this? Divide by 2. So it's pi over 180. Okay? So on your calculator, take and make it a fraction. 165, hit the fraction button, the A, B over C button, and then hit 180. Now, if you have a graphing calculator, that doesn't work. You have to hit the divided by button. So if you go 165 divided by 180, and then do math, and then fraction to decimal to fraction. What do you get as a reduced fraction? 11 pi over 12. Okay, does everybody know how to run their calculator? Because if you didn't get 11 over 12 and you don't know how to do it, I don't want you to sit there and be lost. Okay? It's not shameful to ask a question. Okay? I'm not going to yell at you, Cadence, for asking a question. I'm kidding. Because I know you, I can kid around with you. That's good. That's good. So then you're ready for the ACT come April. No, because that's the day of prom. Yep. So those of you who are planning to take the ACT in April, it is the day of prom. So if you think prom and ACT on the same day are too stressful, then you might want to wait till June to take it. Okay? All right. Okay. So 165. Then the AB over C button. 180 equals 11 over 12. That's easier than trying to figure out what number goes into each evenly. And in this case, it would just be 5. It'd be like 15, probably. I'm not sure. Okay, so we're good there, right? We can change degrees into radians. How about changing radians into degrees? Like 9 pi over 10. How many degrees is that? Well, instead of multiplying by pi over 180, we should multiply by 180 over pi. And what happens? Our pi's cancel. And 10 goes into 180 18 times. 9 times 18 is like, what, 162? $162 degrees. Now, not all the time will it be super nice numbers. Okay? So let's say we have 0.251 radians, and I want to convert it to degrees. I'm still going to multiply by 180 over pi, but I'm going to get a decimal answer. So you take 2.51 times 180, hit equals, divided by, hit the pi button, hit equals, and you get an answer. Okay? So what is your answer? What is 0.251 radians converted to degrees? Fairly small number of degrees. 0.251 times 180 divided by pi. Somebody help me out. Give me one more decimal. Okay, 14.39 degrees. Okay? What if we have 13 degrees 47 minutes and we want to convert it to radians? Well, before we can convert it, we got to make this into a decimal, and then we'll convert it. So what do we do with our 47 minutes? Divide by 60. So it's 13 point what? Go 4 decimal places on this. .7833. And then multiply that by 180 and divide that answer by pi. Whoop, nope. What'd I do? Pi needs to be on the top because this is in degrees. And I want to get rid of my degrees as I'm changing to radians. So take 13.7833 times pi divided by 180. What do we get?
0.2405.
6?
0.2406.
Okay, we're good. I'm good with that. Okay, now, this messes with people's mind, this next stuff, and it shouldn't. But you guys, some of you guys, I should say, don't like fractions very much, and you got to use fractions here, okay? We're going to go coterminal angles in radian form. So if we have the angle 2 pi over 3, I used a really nice example to make it easy. 2 pi over 3. What's coterminal with that? Well, if you think back to the first section, coterminal angles are how many degrees apart? 360. So in radians, 360 degrees is how many radians? 2 pi apart. So we're going to add 2 pi to this. But we can't just add 2 pi. We're not going to get 4 pi over 3. That's not right. To add, we need a common denominator. 2 pi over 1 is the same as what over 3? 6 pi over 3. So 8 pi over 3 is coterminal with 2 pi over 3. Okay? What's the next bigger coterminal angle? Well, then we add another 6 pi over 3 to it, and we get 14 pi over 3. These are coterminal angles. Well, if I would go smaller, what's 2 pi over 3 minus 6 pi over 3? What's 2 pi over 3 minus 6 pi over 3? Negative 4 pi over 3. Okay? So we can find coterminal angles, right? 13 pi over 16. What's coterminal with that? What are we going to add to it to find a coterminal angle? Well, you add 360 degrees, which is how many radians? 2 pi. What's 2 pi radians with a denominator of 16? 32 pi radians. So 13 plus 32 is 45 pi over 16. Well, if we take 13 pi over 16 and subtract 32 pi over 16, we get a negative 19 pi over 16. These are coterminal angles. What's coterminal angles? They're the angles that are in the same position on the unit on the circle, okay? But they have different values, okay? So 13 pi over 16 is like somewhere like that. So this is 13 pi over 16. This is 45 pi over 16. And then, whoops. And then this is, oop, that was right, just right to there. That's negative 19 pi over 16. Okay? Okay. So, if I have, 2 pi over 5, What quadrant am I in? 2 pi over 5, what quadrant am I in? Now, some of you smarticuses can figure this out just by looking at this, because this is 90 degrees, this is 180, this is 270, and this is 360 degrees, along with 0 degrees. Okay? So, 90, if we do radians, 180 degrees is pi radians, right? Because there's 2 pi and 360 degrees. So this is 1 pi radians. So this would be 1/2 pi, or pi over 2. This would be 1/2 pi, or 3 pi over 2. Okay, so that's how we write it, pi over 2 and 3 pi over 2. Okay, so this is 1/2 of pi. How does this compare to 1/2 of pi? Is it bigger or smaller? Is 2/5 bigger or smaller than 1/2? Smaller. So 2 pi over 5 must be somewhere here, which would make it quadrant 1. How about 12 pi over 7? Now, frankly, I have no idea where that is exactly. Well, I do. I know what quadrant it's in, but you might not know off the top of your head. What I would suggest to you when you get to these problems, it's tough to know where they are as in terms of pies and fractions and all that, but it's easy to know where they are in terms of degrees. So multiply by 180 over pi and turn them into degrees. Just take the easy way out. Take 12 times 180 divided by 7. If we take 12 times 180 divided by 7, we get how many degrees? 308 degrees, about, which is somewhere in quadrant number 4. So to find the quadrants, I would change them to degrees. Just a little easier that way. Okay, makes things just a little bit easier. Okay, yeah, I think that should be about enough to get you going on this. So